Hello folks, this is Shraddha Bharti, and in today's lecture we are going to discuss a very important topic, that is center of gravity. We are going to discuss about center of mass, we are going to discuss about centroid and the difference between them. And we'll also learn how to find them. So let's start. So what is center of gravity? The center of gravity of any body is an imaginary point about which the whole weight of the body is assumed to be concentrated. Now this is a very bookish definition and we couldn't understand anything. So let's first try to understand what is the center of gravity. For that, let's consider a 3D body. This is a body and I have placed this body in the axis. This is x-axis, this is y-axis, and this is z-axis, suppose. And the weight of the body is W. Now this body is composed of small elements. Let's say these are the small elements it is composed of, and the weight of each small element is dW, and W is the whole weight of the body. Let this blue point be the center of gravity of the body. Now what does that mean? The weight of the body will act in the downward direction, right? Let's assume the y-axis as the datum. What is the distance of this blue point from the y-axis? Let it be y bar. So this distance here is capital Y bar. Now if we take the moment of this body about the y-axis, what we get? W into Y bar, and this moment is same as if we take the moment of each of these small elements about this axis Y, and thus distance is, let this distance be y1, this distance be y2, this distance be y3. So these are the distance of the small elements from the y-axis. So if we just do dw1 into y1 plus dw2 into y2 plus dw3 into y3 and so on, we'll get this exact same thing as the moment of the entire weight of the body at a distance y bar from the y-axis. Now in the form of integral, we can write this as W into Y bar is equals to integration of Y into dW, or we can find this Y bar as integration of Y into dW by whole W, that is the entire weight of the body, or we can also write it as integration of Y dW or integration of dW. So what does that mean? We are finding the center of gravity of a body. This Y bar is the center of gravity of the body from the reference axis Y. This Y bar can be found out by the integral of Y into dW by integration of dW. This is the formula for finding out the center of gravity. It means that it is that point from the reference axis about which the entire body will have the same moment as the small elements from the reference axis. Okay, so now we understood about the center of gravity, and it is concerned with weight of the body. It includes the gravitational force or acceleration due to gravity in consideration. Now we can find the center of gravity with other axes as well, like this distance is x bar, and x bar we can write as integration of x dw by integration dw, and z bar as integration z dw by integration dw. Now we know that weight of the body is mass into acceleration due to gravity, you can say. Can we write dw as dm into g, acceleration due to gravity? Now for finding out the center of mass, what we can do, just replace this dw by dm into g. So what we will get, our y bar will be integration of y dm into g by integration of dm into g. The g and g will get cancelled out and we will be left with y dm by integration of dm. Now this is the center of mass, and it does not include the acceleration due to gravity or gravitational force in it. And the procedure for finding out the center of mass is exactly same as finding out the center of gravity. That is integration of y into a mass dm by integration of dm. Now x bar, how we will find out? Exactly same procedure, x into dm by integration of whole dm. And z bar is z into dm by integration of dm. Now let's consider some more uniform body like this of a cube shown here. Now we know that density is equals to mass by volume, or we can say mass is equals to density into volume. Now if we want to replace the mass here dm, can we replace it by dv into rho, if considering that the entire body is having the same density? What we will do in the expression, we will replace dm with rho dv. It means the body is having a uniform density. So what we will get, we'll get x bar as integration of, instead of dm we will write rho dv. So we'll write x rho dv by integration of rho dv, and rho will get cancelled out, and we will be left with integration of x dv by integration of dv. Similarly, y bar will be integration of y dv into integration of dv, and z bar will be integration of z dv by integration of dv. Now these are the centroid of the volume. These are the centroid of volume, and here we consider that the density of the body is constant. Now if it is a regular body, something like that, with a constant depth, or the depth of the body is constant, then instead of finding the entire volume, can we just consider the cross-sectional area, considering the uniform depth? Now we know that volume is what? Cross-sectional area into depth. So we can write, we can replace dv as area into depth, that is dA into let's say height h of the body. We are taking height or the depth of the body. So by replacing these, what we get, x bar as integration of x into dA into h by integration of dA into h. Now h and h will get cancelled out, and we'll be left with x dA into integration of dA. Y bar as integration of y dA by integration of dA, and z bar as integration of z dA and by integration of dA. Now these, what are these? These are the centroid of the area, or we can say centroid of area, or the center of the area of the body. Now one more thing I would like to highlight is that this y into dA is nothing but the first moment of area. This is known as the first moment of area of the body. So that's all for today's class. Bye bye. Have a nice day. Do like and follow me for more, and follow my Telegram channel, the link of which is given in the description box. Bye bye.